Alright, students. So for today, we are going to start our chapter 4 in statistics syllabus. Alright, so chapter 4, we are going to talk about the discrete random variable, where it is maybe something new to you lah. Alright. Okay, so for the learning outcome for this part, generally we need to know how to construct a probability distribution table. Okay, relating to a given situation involve a discrete random variable x, calculate the mean and also the variance. Right, so for this topic, it actually covers 3 subtopics. So the very first one is about discrete random variable. The second part, the second subtopic is binomial distribution, where I believe that some of you learned it before. And the third one is geometric distribution, which is something new also. All right. Okay, so for discrete random variable, for this first subtopic here, you have to make sure that your probability concept is good enough. Alright, because it is very closely linked with the probability that we learned in chapter 3. Alright, so if let's say your chapter 3 you are very weak on that, that means on this part you might face some problem to get the correct answer. Alright, so you can see that actually chapter 2, permutation and combination, then chapter 3, probability, both are very important chapters for you to apply, okay, in this particular subtopic, the discrete random variable. Okay, so again, if let's say you want to make sure that you didn't face any problem here, just make sure that you go back and do some revision on probability part first, and also the permutation and combination, right? Okay, so let's start with the introduction. Okay, so what is the meaning of random variable? So random variable generally is something like a definition given, okay, and then in the particular question, and after that you can actually write out the outcome. All right, and a random variable can be discrete or continuous. All right, so we are covered the discrete part for now. Okay, so this one is in AS level. Discrete part is in AS level, and then for continuous, we are going to learn it at A2 level later. All right, for statistics. Okay. Right, then now let's start with discrete random variable first. Okay, so when they talk about discrete random variable, what does it mean? It means that the variable can take individual value. Okay, individual values means that the variable can be assigned a value. As an example, x can be equals to 1. Okay, so 1 is individual value, or maybe x equals to 2.5. Alright, so the 2.5 is also the individual value. So all these we call them as discrete random variable. If it is not an individual values, that means that the x is given in the range. As an example, x is between 1.5 until 2.5. So it is given in the range. Therefore, that is not a discrete random variable. So discrete random variable means that it can take individual values. Alright, and after that, usually for all these individual value, you'll be given a probability for every single value here. Alright, so this is what we are going to learn for now for this video. Okay, and then the random variable are usually presented by capital letter such as x and y, and then all their value are presented by the lowercase alphabet such as small letter x and small letter y. Alright, okay, so this is some very brief introduction about the discrete random variable. Then of course to understand it better, then we have to discuss a few examples, and then we try to understand for all the examples there. Alright, okay, so first, before you start, okay, so just to tell you, for this whole session, our main idea is we want to form a probability distribution table. Okay, so this is our final aim here. I want to form a probability distribution table. Alright, so to form this one, what you need to do is that there are some steps that you need to follow. Right, the very first step is example 1. Okay, so for the very first step before you want to form a table is you need to list out all the possible value for the discrete random variable according to the definition that given in the question. Alright, so we take a very simple example. So we start from a very simple one first. Okay, let's have a look at example 1. Right, so if you look at example 1, They said X is equal to the score when you throw an ordinary fair cubical die. All these you actually just need to use some common sense only, okay, to answer it. Alright? Okay. So what is the score when you throw an ordinary fair cubical die? Right, so when you throw a die, what is the possible outcome that you will get? So you just list out all the possible outcomes. So when you throw a die, you will get a 1. You may get a 2. You may get a 3. You may get a 4, 5, or 6. Can you get a 7? No. Alright, so the largest number that you can get is a 6. Alright, so you have to list out all the possible results that you might have, okay, according to the definition given in the question. Alright, so this is the very first step. You need to list out all the possible value first. Alright, so this is a very important step because if you write out the value wrongly, then definitely your whole table later is the wrong one. Yeah, but all this, there's no special technique, you just use common sense, alright, to list it out. Okay, no technique, no formula, nothing. It is just common sense, right? Okay, so we'll start with part number 2. Okay, so when they say the number of hits when you toss a fair coin 3 times. So when you throw a coin for 3 times, what is the possible value for the number of hits that you get? Okay, so maybe when you throw 3 times, right, you get all tail. So tail, tail, tail. Alright, so if you get tail, 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 that means what? That means you are having the number of hits is equals to 0, right? No hit. Alright, so this one means no hit. So no hit means that number of x equals to 0. Because x is the number of hit now. So you get tail, tail, that means x is equals to 0. What is the possible outcome that you might have? So some students might say I get, okay, maybe I got hit, tail, tail. Or maybe you get tail, hit, tail. Or maybe you get tail, tail, hit. Okay, so all this outcome means what? Means that you are having 1 hit when you throw the coins for 3 times. So when you are having 1 hit, to summarize the discrete random variable, you're having x equals to 1. Alright, so all this belongs to case, so you can see for all the 3 outcomes here, you have 1 hit only. Alright, when you throw the 3 coins. Okay, then what else do I have? Maybe you will tell me that, okay, I have maybe hit, hit, tail, or maybe hit, hit, tail, hit, and then maybe hit, maybe tail, hit, hit, right? Tail, hit, hit. Alright, so if you're having this one, all this outcome tell you that you're having 2 hits. So x equals to 2. Alright, then the last one, you might have all the hits. So this one, the outcome is what? Yeah, 3 hits here. Okay, so 3 hits here means x equals to 3. Will you have h, 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 h or not? No, because you throw the fair coins only for 3 times. Okay, so the maximum number of hits that you can get is only 3. Alright, so I hope that you understand. So this is the first step. When you want to calculate, construct any probability distribution table, the first thing is you need to list out all the value of x. Okay, so this is another example. Alright, so I list out all the possible outcomes to let you have a look so that you can list out the value correctly. So again, no special technique, all this based on common sense. Alright. Okay, so if you have no problem, then can you please continue with part 3, also part 4. Try to write out the value of x and y, which is possible. Alright, so or if you want, you can pause this video and then try it out on your own first. Then only you come back and check with the answer. Okay, so for part number 3, what do I have? Okay, so they are talking about your profit in dollars when you play a game with an entry fee of $1 and the price of 5 and also 10. Alright, so they are talking about your profit. Okay, so entry fee is $1. The prices are 5 or 10. Alright, so if let's say you are winning a price of $5, you have to minus it with your cost, which is $1, right? So your x can be a 4. So when you are winning a price with $10 minus 1, you get a 9. But when you are playing a game, it means that it is guaranteed that you will win the prize, right or not? Therefore, you also need to consider the case where you didn't win any prize. So if let's say you didn't win any prize, it's 0, and then you minus the cost, which is -1. So the -1 here tells you that you actually didn't make profit. You are actually you lost $1. Okay, so the value can be negative, no worry. This value can be 0 also. I mean, if let's say in other example, the x can be 0 also. Alright, so can be negative, can be 0, as well as it's an individual value. Alright, okay, then now, part number 4, what is y? Y is the number of times you toss a coin until a deal occurs. So when you throw a coin, okay, so if you throw a coin first time, one time, you get a head. Oh, sorry, until a tail occurs, right? So that means, okay, maybe you throw first time, you get a tail already. So for this one, how many times you toss a coin? 1, right? So the y can be a 1. How about if let's say you are not so lucky, the first time when you throw the coin, you get a head, and the second time you get a tail. So this one means that you are throwing it 2 times, right? You throw the coins for 2 times, therefore y equals to 2. So if let's say you throw it 3 times, that means first 2 you get a head, the last one only you get a tail. So this one can be y equals to 3. Okay, then if you continue, you can have head, tail. That means you're throwing it 4 times to get a tail. So y equals to 4. Is there any limit for you to get a value of y? If let's say you're really, really unlucky, then that means you can throw many, many, many times, but you still cannot get a tail, right? That means the value of y can be all integer, positive integer until infinity. Alright, so this is also one type of discrete random variable. Alright, so by looking at these 4 examples here, I hope that you roughly now have an idea how we actually list out the value of x and y, x or y correctly, okay, according to the definition of the discrete random variable. Okay, so this is the very first step always. Alright. Okay, so if let's say this part have no problem, then we proceed further. Okay, so when you list out all the value of x already, a list of all possible value of the discrete random variable x together with their associated probability, we call them as a probability distribution table or probability distribution. Okay, the value just now that you get, and also you try to find out their probability for every single value, you combine, not to say combine, you write them out together in a proper way. So we call it as a probability distribution. And then usually for the probability distribution, you can express it in 2 methods, 2 ways. The first one is a table, another one is formula. Okay, so I can tell you very honestly, the table one is much more easier. Alright, formula one, you have to go and think about the formula yourself. So I don't think that it is easy. So for us, usually we'll just put it in the table form. Right? So how will a probability distribution table look like? So this is actually one of the example. Okay, this is one of the this is the example of a probability distribution table. So you'll see that on the first row here, you list out all the value of x that you get, like what we did just now, like in step number 1, example 1. Okay, so as an example, if like just now, your part 2, example 1, part 2, x is equal to 0, 1, 2, and 3, right? So you are putting it as 0, 1, 2, and 3. Okay, and then after that, the second row, you are putting in the formula, sorry, the probability of each value. So what is the probability for you to get all tail? That means no head. What is the probability for you to get 1 head, 2 tail, and so on? All right, so this is a very important partner. Okay, once you list out the value, which is easy, I think this step is very easy, and then you need to also think how to find the correct probability. This is the part that usually students will feel it is quite challenging. Okay, so to find the probability, again, how to find the probability, you need to use back all the concepts that you learned in chapter 3 before. Okay, no shortcut, you have to go back to chapter 3, all the concepts, all the methods that you learned, you might need to apply it here. Yeah, all right. So eventually you'll see that, okay, our final answer usually is in table form. So we call it as probability distribution table. All right. Okay, then now for this probability distribution table, there are a few things that you need to know. The first one is very important. the probability that you list out. So all these are the probability. Okay, every single value here, all the probability that you list out here, the value must be between 0 until 1. It cannot be negative value. It cannot be any value more than 1. If let's say you get any value more than 1, definitely that whole part is wrong. Okay? Alright, then after that, when you add all the probability together, it is always equals to 1. So that means if you add this one, P1 plus P2 plus P3 plus every single value probability here, the total value must be equals to 1. If you total add them up and you didn't get it is equals to 1, that means something wrong with your answer here. You have to check out which part you did it wrong with. Alright, so for sure, it must be the total of probability equals to 1. Alright, so these two are important concept that you need to know about this probability distribution table. Okay, alright, so this is a very simple discussion. Alright, okay, on this probability, again, the techniques and methods you need to use back all the concept that you learned in chapter 3. Alright. Okay, so maybe you can have a look how to maybe form a probability distribution table. Okay, so we start with a simple example first. You can have a look for example 2. Okay, so example 2 is a very easy example. Why? Because they already give you a probability distribution table. Can you see that? Okay, this one is too early. I don't think that they will ask you this kind of question in the exam. Okay, but this example mainly is for understanding, right? Okay, so if they already give you a probability distribution table, and then let's see what they discuss, about this, what they say about this. Okay, you are having a biased 5-sided spinner marked with number 1, 2, 3, 4, 5. So you can see all my value x here is 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, and then when she spins the spinner, her score is the number of which the spinner lands, and the probability distribution of x is shown in the table. So they already tell you to get a 1, to get the value x equals to 1, the probability is 0.15. To get the value x equals to 2, the value is 0.4, and so on. Alright? Okay, so first they want you to find the value of a. Okay, so I think this is very easy. Okay, you have to use a concept that you learned just now. Right, so what we learn about this table is when you add all the probability together, it is always equals to 1. So you are using this concept. So 0.15 plus 0.24 and so on. Okay, so you try to add all the probability together, it is equals to 1. You learn it equals to 1. Alright, and after that, I want to show you the detail. Okay, so eventually you should get the value equals to 0.17. Okay, so by using this concept, you can get the value for A. Right, okay, then second part. Find the probability that the score is at least 4. Score means X. So they want you to find the probability that X is at least 4. That means more than equals to 4. Okay, so where do we have X more than equals to 4? Okay, so you can see it's this part and also this part, right? So they actually want you to consider the probability. So that means you need to take 0.25 and then add with 0.19. Because these two, the score X are equals to 4 or more than 4, at least 4. So you have to consider the probability and add them together. So you're having 0.25 plus 0.19, which is equals to 0.4. I think this is not hard for you to understand, right? Okay. Right, then how about for the next one? Part number 3. Okay, so for part number 3, they want to get a score which is less than 5. Less than 5 means that the score can be 1, 2, 3, and 4. 5 is not included. Okay, so if you either way is add all the probability for 1, 2, 3, 4, add them together to get the answer, or if you don't want, then you can just take 1 minus 0.19. 1 minus x equals to 5. Okay, this is shorter to me, I think. All right, so you should have 0.81. Okay. All right, then for part number 4, you do it on your own. I don't want to discuss it with you. I think it's very, very simple. Find the probability of x between 2 and 4. 4 is inclusive. Okay, so if let's say you add the probability correctly, you should get 0.42. All right, then the last one, part number 5, write down the most likely score. Okay, so when you're looking at this, most likely score means that the score that has the higher chance to appear. Right, so highest chance means that you're looking for the highest probability. So the highest probability is 0.25 here. And they're looking for the score. So the score for 0.25 is 4. So you can just straight away write out x equals to 4. It's the most likely score. Alright, so this example generally is very simple. They will not ask you in the exam because it is too simple. They already give you the probability distribution table. So this example is mainly for your understanding about the table. And also the question that they might ask, a simple one. Alright? Okay. Okay, so no problem. Then maybe we can proceed to the next example, which is a bit more challenging or maybe harder. Okay, so you can have a look for example 3. Okay, you can read the question first and before we start to discuss it. Right, so what can you see here? Right, so you can see that, okay, we are having a basket with 12 petals, and then there are 3 red, 4 green, 5 yellow. And then 3 peppers are taken at random without replacement from the basket. Okay, so first part, they want you to show that the probability that exactly 2 of the peppers taken are green is 12 over 55. Okay, so now you are going to take out 3 peppers at random. Okay, and then they want you to find out the probability that 2 of them are green. Okay, so how to find out the probability? Exactly 2 green peppers. Okay, so there are 2 ways for you to do it. The first one is, okay, you look at the green pepper. So we divide it into 2 groups. One group is green pepper, another group is not green pepper. Okay, to get 2 green pepper, that means what? That means we are choosing 4 or 2 from 4. Right, so it's 4C2. You are having 4 green pepper in total, you are going to choose 2. And then the rest of the color are red and yellow, right? I don't mind what are the color of them. I just total them out, which is the 8. You're having 3 red and 5 yellow. So you're having 8 other color one. You want to choose 1 so that you make them a group of 3. Okay, then divide by total without restriction. So total without restriction means that in total you're having 12 petals and you want to choose 3 of them regardless to the color. Alright, so this is the combination methods that we learned previously in chapter 2 and 3. So you have to apply all those concepts, right? That's why you have to be very familiar with chapter 3. If not, you face a very big problem here also. Okay, right, so when you press 4C2 times AC1 divided, okay, so you just press calculator and try and see. You should be able to get the answer 12 over 55. Okay, so if you successfully get the answer that they want you to show, that means what? That means the method that you are using is correct. So use the same method to apply in the next part later. Alright, so that's why they ask you to prove that the probability that you get is this one, to make sure that the method that you are using, okay, to get this answer is the correct one. Alright, okay, so this is the way that we do exactly 2 green peppers. Okay, So just like I told you that for another method. Another method is what? So this one is combination. Alright, so or another method is something like this. Okay, to find out the 2 green pepper. Okay, so some students will say, okay, 2 green pepper means that the first one I get is a green. Okay, if the first one that you get is a green, it will be 4 over 12. Right, you're having 12 pepper in total, and then you're having 4 green peppers. So 4 over 12. After you take out 1 green pepper already, this one is left 3, and then the total become 11. Alright, so the next one, if you still get a green pepper, means the probability become 3 over 11. Okay, and then the third one, you don't want the green anymore, you want other color. Alright, so this one become 2, this one become 10. Alright, so the third one, if you want to get other color, that means you are having 8 out of 10. Okay, so you can find out like this, but this step, when you write it out, it is mainly for G, and green, and non-green. Okay, but you have to consider also besides the green, and non-green, maybe your arrangement can be green, non-green, and green. This one also means 2 green pepper, right? And then you might have non-green and then green. This is also another case that you're having 2 green peppers. Alright, so you can multiply with 3 if you want. There are 3 different arrangements. Or you can use a shortcut that we learned before or formula that we learned before. You just look at this one. You're having 2 green and 1 non-green. Okay, so these 3 items, alright, 3 items. When you want to arrange the 3 items, means multiply it with 3 factorial, but there are 2 identical green pepper here. Therefore, you need to divide it by 2 factorial. 3 factorial divided by 2 factorial also get a 3. If let's say you just now list out the cases, you multiply it with 3 because you're having 3 different cases, right? It's the same thing actually. Alright, so this one you just apply it with commutation. Okay, so you should be able to get the same answer also. Alright, so yeah, you have 2 ways to get the answer. Okay, so which one is easier? For me, of course, this one is easier, the first one. Alright, I don't need to consider so many different arrangements there. Alright, okay, then after that, we'll continue now. Okay, so let's have a look at part number 2. The number of green peppers is taken and denoted by the X. Draw up a probability distribution table for X. Okay, so now you need to consider already, yeah? X is the number of green peppers. Okay, so what is the possible value? What are the possible value for all the X here? So again, on common sense, you want to choose 3 peppers, and then when you choose the 3 peppers, right, it is possible that you didn't get any green peppers. You might get only 1 green peppers. You can get 2 green peppers. You might also get all 3 green peppers. Can you get 4 only for this case? No, right? Because maximum you are going to choose only 3 peppers. So the maximum number of green pepper can be 3 only. Cannot be 4. Cannot be more than that. Alright? Okay, so the value for X equals to 0, 1, 2, and 3 are all the possible value, okay, for your discrete random number. Okay, so once you know that all the value of X already, then you can start now finding out the probability. So X equals to 0. That means there's no green pepper lah. Okay, so no green pepper means for green pepper, you choose 0. Multiply with what? Other color one, you are choosing all 3. So it's C3. Divided by what? 12? C3. Okay, so please take note that I'm using the same idea. That's why I use in part 1. Because from there, I already know that the method is correct. Therefore, I'm applying the same concept and idea here in part number 2. Okay, but I just change the value according to the question. So they're asking for no green pepper. So it's 4C0. 4 green pepper, choose 0. Okay, other color one, 8, choose 3. And divided by the total without restriction. Okay, so the first value here you should get 14 over 55. Okay or not? Alright, then how about for X equals to 1? Okay, then for C1, 4 choose 1 green pepper, right? We are having 1 green pepper, then 8C2 divided by 12C3. Okay, then you should be able to get 28 over 55. Okay, then x equals to 2. I'm not going to find it out because x equals to 2 is the answer in part number 1. 2 green pepper, so x equals to 2. Alright, so I'll straight away skip to x equals to 3. So for x equals to 3 means that for green pepper, you choose 3, multiply with 8C0 divided by 12C3. So from here, you should be able to get 1 over 55. Alright, so you already find out all the probability for the value of x already. Then final answer is you need to draw a table. Okay, so when you draw a table, it depends on how you want to write it. So usually for me, I will just write as x and p. Okay, so for the value of x, I'm having 0, 1, 2, and 3. And then for the value of p, I'll put in the value that I find. So this is 4 over 55, 28 over 55. Then for 2 green pepper one is 12 over 55. And then 1 over 55. And then after I list out everything here, usually I will just double check. I will add all the probability that I get, okay, and see whether I get the total equals to 1 or not. If let's say the total equals to 1, that means you're having a higher chance that to get the answer correct. Okay, but if let's say your answer is less than 1 or more than 1, definitely answer is wrong. Definitely. Alright, so it's a simple way for you to check on your answer. Okay. Alright, so for those who are interested, if you want, you can actually try to use this method again. Okay, to see whether you're able to get the answer or not. Alright, okay, so again, this is a complete question. Like, how are you going to use the concept in probability to form probability distribution table? Alright, so some question can be very simple. Some question can be very tough. Alright, so you have to try a few more to make sure that you understand how to get all this. Alright, so for the rest of the example, I will discuss it again in the next video. Right?